Well, greetings everybody. So here you'll see a problem that is from the assignment, and it involves the chain rule, but I think what makes it complicated is it involves three nested instances of the chain rule. And it's a little bit difficult if you're just learning the chain rule to work this problem all in just one giant step. So I've broken it down into three parts, and I think if you can understand the individual parts, then you can understand the whole problem. All right? So here is the function that we want to find the derivative of, and that's given here. Okay, I have that question in my third part, but I want to work up to it. So here's how it's going to be. First, let's talk about all the rules that are involved in this example individually, and then I'll use them one at a time to get to that ultimate question. Okay, so here are the three rules. Now, in each of these rules, what you see here as u is some function of x. It's some more complicated function of x. So instead of like u to the n, we might see this function sine of cosine of 8x to some power n, like 4. Okay, so that's one rule. Now, the derivative of that is n times u, whatever the u happens to be, however complicated that interior function is, to the power n minus 1 times du over dx. What is du over dx? It's just the derivative of that function u, whatever it is. Okay, so that's the chain rule for the function u to the n power. What about sine of u? Where again, u is some function of x. The derivative of sine of u is cosine of u times the derivative of u, whatever that happens to be. That would be kind of like this first example or this second example. Okay, sine or cosine of some other function. Cosine of 8x or sine of cosine 8x. Okay, so the rules for those are right here. Derivative of sine u, derivative of cosine u. So those are the rules as they are individually. Now here's how we'll use them together. Okay, so let's first think about this. Could you use those rules to find the derivative of cosine of 8x? If that's y, what's y prime? What's its derivative? Well, that would just be a case of this third rule right here. It's cosine of u. So by that third rule, given that u is 8x this time, it's going to be, okay, minus sine u, so minus sine 8x, okay, u is 8x, times the derivative of 8x, whatever that is. What's the derivative of 8x all by itself? It's just 8. So do you see I use that rule right there just for this? We could rearrange a little bit. I could write this 8 as a coefficient with that negative 1 and get negative 8 sine of 8x. Okay? All right, now that's my first part. And I'm going to build on this at this point. This first part is, can you see this simple instance of the chain rule and how it applies to that function and why this is the answer? Now let's build on it. What about instead of just cosine 8x, what if you had, part 2, a function that is sine of cosine 8x? Now this time, we've got the sine function, but we're taking sine of u, some other more complicated function, this time cosine 8x. Well, this is the rule. This second rule, rule 2, that's the rule that would apply. How would it apply? So the derivative of sine of u, sine of cosine 8x, is cosine of u, so cosine of cosine 8x, then times whatever the derivative of cosine of 8x is. What's that? That's what this part should be, according to that rule right there. Well, the derivative of cosine 8x, that u function, we just did that. So that's negative 8 sine it. We've already done. It's right there. So, okay, that goes here. So there it is. There's the rule. Cosine u du over dx. Cosine u times the derivative of u by the chain rule. Okay? Rewriting it a little bit, putting the negative 8 as a coefficient like that, we get this way. Okay, so now we did a simple example. Now I did one based on that where I used the answer to the first one. You see how if these functions are nested inside each other, do you see how like maybe we could work it in little parts and put the answer together that way? Now doing part 1 and part 2 like that, if you understand that so far, that's everything I need for part 3. Okay. Part 3 is the example given here. Sine to the fourth power, or you could say sine of cosine 8x to the fourth power. Now, I think it's important you see how the functions are nested. It's important you see what the u is. Like here, you must see that we have sine of u, and that u is cosine 8x, and we use the rule accordingly. Cosine u du over dx. I think it's a little hard to see how the functions are nested inside each other when we write sine to the fourth power like that. So instead of writing it the way you see it in this question, I'm going to write it a different way that I think makes the order of operations in that function, or the nesting of those functions, more obvious. I'm going to write it like this. That's how that exponent applies, actually. If you had to, calculate this number, like if x is a known number at some point, the order of operations would be you take x and you multiply by 8. Then you take the cosine of that, and you get an answer. Then you take the sine of that, and you get another answer. And then you take that and you raise it to the fourth power. That would be the order of operations. I think it makes it a little more obvious this way. So the question here in my math lab is, can you find the derivative of this? Sine of cosine of 8x all to the fourth power. Now, I hope writing it that way makes it really obvious. Which rule would it be? It'd be this one, u to some power n. You've got some function u, however complicated it is, raised to some power n. In my case, the u is sine of cosine 8x, the power is 4. This first rule applies. Here's what we do. According to that first rule, power comes down to the front there like a coefficient. Then I get u right here. Okay. This is 4u, and then to the third power I subtract 1. And that's it for that part. That's like n times u to the power n minus 1, just like that rule says. And then this part, whatever it is the derivative of the u. It's the derivative of that inside thing. It's the derivative of sine of cosine of 8x. That's what this needs to be. But because I did this in pieces, we've already done that. You see? So I've worked my way in through this thing. Now, if you were doing this and you didn't see ahead like that, then you'd get to this part and you'd say, well, now I just have to figure that out. But I've already done it. Okay. The derivative of sine of cosine of 8x is right there. So see this? We already did that in part 2. That goes here. All right. Now we'll do a little rearranging, and I could say, well, I've got a negative 8 right here times all that. I've got a factor of 4 there. I could multiply those. I get negative 32. I've still got this grouping all to the third power. I've got that. I got that. But it is the answer. It's the correct answer. It looks a little different, but let's compare. Okay, I'm going to try to drag this down. Okay. Let's see if I can get it to show up. There we go. Okay, the only difference is, just like in the beginning when I rewrote with that exponent, you see how right here they'll put the exponent right there on the sign. So instead of a bracket to make it obvious that we have sine of cosine of 8x all to the third power, you might just write that power, that exponent right there like that. But that is this answer, okay? You can look at it. Everything's there. Maybe the arrangement's a little bit different, but every factor's there, and I've accounted for everything, okay? All right, so that's how I would think about this one if I was to show you how to do it. If you were to just start with the problem right away, like I mentioned, you maybe do this part okay. You bring that power down, you take away 1, you get the 4 and the 3, but then you got to find the derivative of that function in there, that u, okay? That's what this part is. So at that point, you could pause, and you can kind of think back the way I did here and back there, okay? So you might go through it backwards. You might start with part 3 and then figure out you got to work back to part 2 and part 1. But nonetheless, if you can do all these, you can put them together into that final answer. And that's all that I want you to see from this, however you go through it yourself.